For this problem, we're asked to use vectors to determine the minimum tension a cable must endure. We've got a 1,200-pound chandelier that's to be suspended over a large ballroom. The chandelier is going to be hung on a cable whose ends are attached to the ceiling 16 feet apart. The chandelier will be free hanging, so the ends of the cable will make equal angles with the ceiling. The top of the chandelier is to be 16 feet from the ceiling. We want to determine the minimum tension the cable must be able to endure. Go ahead and draw a diagram here. We have some forces. We've got the force one cable going in this direction, force 2 is cable going the other direction towards the ceiling, and then force 3 is going to be gravity. The weight is 1,200 pounds. And we'll imagine this is our chandelier. The wires are attached to the ceiling, or the cables are attached at a distance of 16 feet apart along the ceiling, and the chandelier is hanging 16 feet below the ceiling. We're going to use this right triangle that we've sketched here to conclude that the tangent of alpha is equal to 16 over 8, which is equal to 2. And so alpha is equal to the tangent inverse of 2, which is approximately 63.43 degrees. The three force vectors in the problem can be written as F1 is equal to the magnitude of F1. Now that we've determined the angle alpha, we can go ahead and write down our force vectors. We want to write down our force vectors broken into their horizontal and vertical components. So we're going to get that force 1 is equal to the magnitude of force 1 times the cosine of 116.57 degrees with the unit vector I, plus the sine of 116.57 degrees times the unit vector j. So we have our horizontal and vertical component. Force vector 2 will equal to the magnitude of force vector 2 times the cosine of 63.43 degrees, the unit vector I, plus the sine of 63.43 degrees times the unit vector j. Our third force, force 3, is equal to negative 1,200 J. It's only in one direction, it's all straight down. Since the system is in equilibrium, we need F1, or force 1, plus force 2, plus force 3 to equal 0 times unit vector I plus 0 times the unit vector J. This means that we'll get the magnitude of force 1 times negative 0.447 plus the magnitude of force 2 times 0.447 plus 0 must equal 0. So we're looking at the horizontal components. We're summing those up. That needs to equal 0. We'll have the magnitude of force 1 times 0.894 plus the magnitude of force 2 times 0.894 minus 1,200 must equal 0. So here we have the vertical components of each of our forces. When we add those up, that needs to equal 0. We can now use these two equations to determine the magnitude of force 1 and force 2. The first equation gives us that the magnitude of force 1 must equal the magnitude of force 2. If we call this common value the the magnitude of F, where F is that common force. We can substitute that into our second equation to get 2 times the magnitude of F times 0.894 is equal to 1200. Or we'll get the magnitude of F is equal to 1200 divided by 2 times 0.894, which is approximately 671.14. Therefore, the cable must be able to endure a tension of approximately 671.14 pounds.